let's look at how we can differentiate the natural log of blah. So I'm going to show you some different situations and how you differentiate them. So we're going to start with this one down here. So we're going to say that in general, the natural log of something is the same as 1 over something. So for our first one there, that's what we're going to do. So we're going to say that if y equals the natural log of x, then when we differentiate that, we just get that dy dx is equal to 1 over x. Okay, so that's kind of like our basic result that we need to know. So how are we going to handle number 2? So we've got a 2 at the front. So what we can do in general when we differentiate with numbers at the front is we just keep them out of the way and we put everything back later. So let me show you what I mean. So if you differentiated, let's say 2x squared, yeah, so what would you do? You would say 4x. But a different way that you could have thought about this question, you could have left that 2 over there, and then you could have differentiated the x squared, and you would have got 2x. You'd put the 2 back, so it would also be 4x, okay? So we're going to use that idea as well. So what we're going to do is we're going to say that 2 natural log of x is the same result as before, and you just have it twice, okay? So if y is 2 natural log of x, then we're going to say that dy dx is equal to 2 lots of 1 over x. Or a better way of writing that would be simply 2 over x. Okay? Well, how about number 3 then? So is number 3 the same? So number 3, then this is quite sort of an easy mistake to make, is actually also 1 over x. So let me show you why this is. So when you have logs, you might remember that if you have log of a product, so something like this, well, that's the same as saying log of A plus log of B. Okay, so you need to remember that because that's going to be useful. So if I said the natural log of 2x, I'm going to rewrite it before I differentiate. So I'm going to say that that's the same as the natural log of 2 plus the natural log of x. Well, the natural log of 2 is actually just a number, isn't it? And what happens when we differentiate numbers? Okay, they'll sort of differentiate away, they'll disappear. So we'd actually only be left with this one. And we know what the natural log of x differentiates into, don't we? It differentiates into 1 over x. So this is a little bit of a surprising result, really. But the natural log of 2x is also just 1 over x. Okay? In fact, in general, the natural log of an x, but with a number at the front, is just 1 over x. Okay, so that's a special result to watch out for. How about our final one then? So how do we do number 4? So number 4, you actually need to know something called the chain rule. So there is a function here, that function's x cubed, and that's inside a bigger function called the natural log of x. So let's do the outside bit. So it's still the natural log of something. So you may have now seen that if you have sort of like the natural log of a thing, as long as it's not a special case, it pretty much is the case that it turns into 1 over that thing. Okay, so that's actually the first part of it. Now the other part, you need to know the chain rule if you're doing this, otherwise this isn't going to make sense. So you have to have the outer bit differentiated, but you also need the inner bit differentiated. That's the inner bit there. Okay, so x squared differentiated is 3x squared. You can tidy this up by writing 3x squared over x cubed, and then you could actually even simplify that a little bit. So it becomes 3 over x. So in general, when we differentiate the natural log of blah, we get 1 over blah. Watch out, though, for the cases that look different but are actually the same.